screen. Oh, excellent, Gabby. And I think if people are okay, I'll try to do the same thing last week where I'll just we'll walk through the we'll walk through the code. Like I actually think that this data set was a little wonkier than the one last week, and so I'm actually kind of curious what people are thinking. Does my share screen work? Amazing. So so bee colony losses. So I'm just going to load so similarly, it's Nicola follows the exact same process that you did in the week before, which is exploring the data, coming up with some sketches, and then really preparing a plot. And you'll see when she explores the data that she's got like a very much a vision in mind for how she wants this plot to look. And so when I loaded the data, and so she says in the book, it's about bee colonies, and it was in reaction to, I think that they had shown that there had been recent bee colony losses. And so she was kind of interested in being able to show that. And so she first of all loads the data and she's kind of like curious, okay, so what does this data look like? And she uses a box plot. Um, and so for those of us who seen box plots are showing where the distribution of the data is. So you can see that like nearly all of the distribution of the data is over on the left-hand side because the entirety of the box and even both whiskers are over there. And so she's like, okay, so there's a lot of outliers to deal with here that we have to think about where do those outliers come from. Hold on. I'm sorry. So there we go. So I'll also just show like again I really again really like being able to show to look at the data as a table, especially when you can use something like positron, which can show what's going on. And so something that she mentions, but I think is useful to know, is that the data set takes place, there's basically four different time periods that the data has. So January to March, April to June, July to September, October, December. And you'll notice that they actually don't all have the same amount of data, which she kind of gets into as well. And then the colony N has a huge range, you can see from the outliers, but a lot of it is over here, which she again also talks about. So she's trying to figure out why is that happening. And so she's got these outliers over on the right-hand side. She's like, where could that be happening from? And so what she does is she instead switches it as this as a box plot here. And this one I actually like. I'd be curious if we like, I'm actually gonna here, let me see if I can open it in a new window. Yeah. So I'm actually kind of curious looking at this. So she notices one big thing, which is that the United States is listed as a state. And so that is where nearly all of the outliers are coming from. Any place you have the United States, that's obviously going to show up in the box plot as something far over. I was actually wondering, looking at this, um, because I stopped and looked at this and I thought that if I was thinking about like how to come up with this as a plot off of Tidy Tuesday, I was wondering what other things like just looking at this, what is interesting to you about about this plot?
So I would say that there are states so there's 50 states, right? So that's a lot, first of all. But second of all, the majority of them behave similarly, but there are a couple, like, I guess that one's, is it Colorado or California? One of the two.
California.
Yeah, I
Yeah.
can't see. Oh, yeah, of course, California. That is going to behave completely differently. And then same thing with North Dakota. Not completely, but enough to be different. And then the other one that's up here, what's that one? Oh, that's for all the United States?
Yeah,
I guess I would remove that one because then it's not the same category as just all the states or just all the states combined. That I don't know. It depends on what you want to
yeah,
do, but that one encompasses everyone. So I guess that jumps out.
yeah. That's what Nicola's big noticing from this was the United States. Um, I'm also kind of interested in the fact that not all states have the same area. And so something that strikes me is that like some of these, like California is a big state. And so, but North Dakota is not that as big. And so I'm almost something that made me curious about was would you like if I were to really try to dive deep into this, would I actually want to figure would I want to like almost bring in the area of a state to actually get a density calculation? Um, that was one thing I was interested in. And then I similarly like you'll see what she does. She describes just picking a few states and then trying to California, North Dakota, Florida, Texas, Idaho, and South Dakota. So when she does that later on in the chapter, you can see that those were the states that have the most, that have the majority of the bee colonies. And so what, like what Gabby said, she was trying to pull that up. The other thing that she wanted to do was Nicola introduced this VizStats library, which I'm actually not sure is on this computer. So I might have to, yep, in the moment, install. So she introduces this VizStat, which is really good at, if other people, as I interpreted this, what it does is for every single row, so the top of the row down to the bottom, it will tell you um, where is there missing data. And so it was saying that there was missing data in this towards the end of the data. So that's like the 2022, I think this runs until, and some of these didn't have 2022 data. And then there was also like a set of years, it was 2020, it was pandemic, where they also were missing data as well. So I thought that was really cool and something that I kind of think that Positron actually sort of does a little bit for you. So this is where she gets to her sketch. And her sketch is pretty interesting in that, oh, it's a broken link. Oh no. Ready, data station. Let's go to her. Oh no. She really wants a dot density. Yeah, that'll be why it is not working. Sorry, I'm at a school, and as you can see, they've put a firewall up for certain images, and that's okay. So what she wanted to show was a dot density plot. Gabby, if you can bring it up, if you want to share screen at any point with her sketch, like that would be kind of nice, but it's also okay. Because what she really wanted her sketch to be was she wanted it to be a dot density plot where you could actually see what the different, instead of seeing it as a number, to see it as like almost like she's imagining like the beehives where like you could see them plotted along, except it's like something that's similar to that. And so to do that, she decides to do a few things. She wants to limit the states, and then she's not only limiting the states, but she's limiting it to one set of months in the year and selecting out of the colony. So if I do that and I now go to the plot data, what I have is for each year in those months for those 5 states, how many bee colonies estimated are there? And so what's kind of interesting is you could kind of stop right here and you would actually have something that would be pretty easy to plot. So I think you could just do ggplot what mapping equals AES x equals colony x equals here Y equals colony, and color equals state plus geo. Like and then you've already got something that's showing, it went up in North Dakota. It's going down a little bit in California, but this is not the point. I think Nicola wants to show you there's other ways of showing this as well than just a line plot. And so, which I actually I will admit that when I was working through the chapter, I did a line plot for a reason that we'll get to. So now she's getting the states. And now what she wants is she wants to be able to make sure when she's got her dot density plot that the dots are not going on top of each other. And so this is where she goes. She's like, okay, so we're going to have these dots go into a Poisson distribution. And why we're using a Poisson distribution is because um, it is a nicer distribution than others for being able to do this. It has enough randomness um, that the dots will not like be in some ways disorganized, but they will not be on top of each other. And so what she does is she creates a Poisson distribution. Forgot to load the library. And so what this does is now you again have all of these things, but now instead of 75,000, this has been divided by a denominator. I want to say it's 2,000. Yes, 20,000, 200,000, 200,000. And then each one of those points is showing because of this. And so, for instance, this one only has 23 points. California has 895 points. And then she actually will unnest those points because they exist in a list. And so now the Blease plot data is every year, state, this, and the X and the Y of a point. And so now she's now ready to plot. And so what you'll see in this plot is, yep, there it is. So again, um, this is what she wanted, is for each of these, it shows it is a representation of how many colonies there are in that state. And she wants to do this to get the impression of the change in density over time. I will admit, um, I think that this is a pretty plot. I don't know if I was wanting to, depending upon the style of communication I was doing, I don't know if this would be the type of plot that I was trying to think about when would I actually really want a dot density plot. Um, but now she gets into her themes. And so now she's instead going to she's got her plot, but now she's got it now her points are yellow. And you can see she changes the size of the points. And now you can see it is yellow on white. So we gotta not do that. So the next thing she does is yep, gets her fonts in. And now she's got there we go. And now she's changing that she doesn't like that these are not squares. And so she instead fixed chord fixed, which means that it will be a square plot where it'll have the same X and Y axes. And then she's using theme void, which is a really good theme to begin with when you really want to start with Scratch, because it basically eliminates all axes and axes plots. And then she's got pretty close to what she wants. The only difference is she still really wants let me see if I have, good. And here we are. And so notice that she kept those yellow dots, but she's using black background, California, all of these things. this isn't showing super nicely on here, but I think if I were to save the plot, then it would. So let's PG save. What's the name of this plot? Oh, trapped. That will see. No. I guess I'm wondering. First of all, I really liked this. I liked look using a little bit of math to using a little bit of math to understand to get to the plot, and once again, see understanding why this makes a dot density plot so well. But I was also wondering, like, if I was doing this for communication, would this have been the plot that I would have chosen? Versus I'm doing it to show like there is many more bee colonies in California, and I get the sense of that. I get the sense that in North Dakota there's been an increase, but I don't know if I know how much of the increase it is by using this kind of a plot. I don't know. What?
I think
Go
that,
ahead, Gabby.
yeah, so with this, I think it's very interesting that you use this because it's a way for you to see. So the way she had it before is like, this is just a number, right? Like 79,000 or 12,000 or 50 or something. This is a visual way of displaying all of that and compare it across. So is this the best way to present your information or your data all the time? No. But I think it's a very visual way when you want to compare things like extreme, like in California versus Idaho, for example. So I love plots that are like this because if I understand correctly, these Poisson, this thing that she did, she's just like resampling using a Poisson distribution for each one of the states and years, based obviously on a Poisson distribution, but so that you can see each of those points that she has for each one of the states and years. But the points have to be, instead of being randomly shown, there has to be the same distance between them so that you can actually identify them.
Hmm.
Um, so it's very cool. I mean, you can see how the difference is so big between California and the rest of the states, but there's not such a big difference between California 2015 and 2020. I mean, I guess there is a little bit, but there isn't that much. So I'm not sure if that's what you wanted to show initially. Um, so yeah, I don't know if that clarifies this a little bit.
Yeah, I definitely see that. Yeah. Oh, when do you think would be another time that you would use this type of a plot?
So every time you're dealing with count data, because that's Poisson. Um, so it depends on what you're working on. I'm an ecologist, so this really represents what I would use it for. But even if you're dealing with people, for example, if you were trying to compare um, visiting, how many visitors you have uh, for three different museums across different seasons or months or afternoon and morning, and you sort of want to compare that, the number of visitors would be another good way of seeing this. And then you can say, oh, we get more visitors in summer, obviously, right? But in summer than in winter. Um, Another thing that you can do this is with like unique visitors to a website. Uh, when is it that they're showing up? I don't know, something like that. Every time you're dealing with count data, I guess it's the way to go here. Because
Mm.
what is she representing? Yeah, the number of points in each square represents the number of, let me go to the book. Um,
Oh.
so it says that the number of points in each square represent the number of bee colonies that exist during the months of October, December of each year. So then each point is a bee colony. Um, so then you have, I'm going to make a number up here. In 2015 for Idaho, you have, let's say 20, but obviously by 2020, you have perhaps half of that, more, let's say 10. So that's counted data, right? So you could see this with, let's say this is a museum, Natural History Museum in Idaho, and the Natural History Museum in Texas or something. How many visitors you get, and then by year, same, or by season. So then each point is a visitor instead of a colony. I
Mm.
would I think that could be another way of seeing this. Um, I'm trying to think something else because it's count data. Yeah, th those are the ones that come to mind.
That makes
For
sense.
for you in the classroom, I don't know how much these things change, but this could also be like uh number of students that do something regarding a test, like they pass a test or they don't pass a test or they something like that. And then you can do this by county or by school. And then you compare them by year, like the number of students that did something or number of teachers or number of schools. Each point is a school, I suppose. It depends, right, on how you aggregate your data.
Yeah, I think the thing I'm struggling with is I would be curious where density is on the you all read Klaus Wilke's Fundamentals of Data Visualization. Does he talk
Mhm,
about like the Cleveland paper that's like ease of reading to like hard to things that are hard to read. And it's like
mhm,
how, for instance, like length is one of the easiest things to read in
mhm,
a data visualization, right?
mhm,
And then like color is less can go further down than that. Like length is the easiest.
mhm,
And I guess the curious thing I'm playing with here is I feel like there's a tension between how easy do you want someone to get the data versus like
mhm,
of true representation of what's going on, right? Bees
mhm,
are all over a state. And so like doing points on a thing is like nice in terms of like from a visualization perspective of
mhm,
I want to show the density of bees legitimately in a state so people get a
mhm,
sense of the scale of that.
mhm,
But you definitely lose a sense of reading, right? You lose a little bit of the data literacy in making that choice. There's a tension there, right?
because you don't start with that and you have to simulate it. Is that what you say? Perhaps, but you don't
I
have to
think what
tell
I'm
that to
saying
the
is,
audience.
so for instance, in the plot, let me see if I can bring
Hmm.
the plot again. So something that I was struggling with in the plot was so the title of the graph is Bee Colony Losses in the United States.
Yeah.
Um, but I don't necessarily get the sense of loss in this plot, right? In fact, the
Ah,
opposite.
okay. Hmm.
Right? So like
Yeah.
North Dakota is actually increasing. That California does decrease over time, but because
Yeah.
of the way the plot was created, you can't tell, I can't count the number of dots in California for each one of these and actually get a sense that this is about loss. Um,
Ah, okay. Hmm. I see
and
what you
so
mean.
that was where, yeah, pardon? That was where I was struggling,
Hmm.
was
Hmm.
I understand if I was trying to get it, I guess what you're getting at is if you want a sense of scale, right? The dot density might be really good, especially when you know the scale increases like exponentially, right? It's
Hmm.
like when you have like if you have like a petri dish and you
Hmm.
start with like just a couple of points and you see the petri dish like getting like slowly bigger and bigger and bigger. But it does, you don't, you lose, um,
Yeah, I think you
you
lose
lose
it
some,
within
yeah,
a state, but you can gain that across the state because you get to see the magnitude of this from California to Idaho, but maybe not
right.
within Idaho, like across years. I think you're right about
Mm,
that. I agree with you. Maybe there's a better way to represent that. And I think you make a good point because obviously this looks great, but after you make your graph, and even though it took you 3 days to do it, you always should go back and say, is this the best way to represent what I want to represent? Is this
right.
really so? If my message is California has way more colonies than Idaho, then for sure, you got it. But if that's not your message, then maybe go back to the drawing board, right? And then start thinking about it again. I think you make a good point because it's not necessarily, even in California, across years, even though I can see a mass of points, can I really get the magnitude of loss here? Does it go from, I don't know, 50,000 colonies to three? Fine, that would be super obvious. But if it's going from 50,000 to 40,000, I'm not going to get that from that plot. I think you're right about that. Is that what you're trying to say? Did I get it correctly?
That's exactly right. Yeah, that's exactly right.
Hmm.
Yeah, yeah. I was actually playing with what she did in the chapter before,
Yeah, yeah, yeah.
where she set, she set the number of museums per district to each
Uh-huh.
other and did change over time.
Hmm.
I actually was playing with, oh, what would it mean to play with change over time? And
Yeah.
so hold on, let's see if I
Yeah,
have,
because that's
let me see
Poisson.
here.
It can be either space or time. Yeah.
Right. I don't know if this will work. Here, let me just see.
I will say this, at least this is a way that I have never thought about representing data before. So I learned that. That's
Mm.
a little gem right there, because I
Oh,
think
totally.
that I've never thought of that. Is it the best for the bees? Perhaps not, but I learned. I learned a lot
Yeah.
from Nicola, as always.
Oh yeah, I completely agree with that.
Yeah, right. So maybe, yeah, maybe we should do that exercise. Like, what would be the best way to represent
Well,
this loss?
right, for a different, yeah, depending upon your audience, right? Like,
Hmm.
yeah. Yeah, I think that's I think you're naming what I was struggling with while reading this.
Yeah. Gráficas y cosas. Do you have the graph, John?
That I did before. Yeah, I did, yeah, I made this using the same data.
Okay, let's see. Ah, yes, I saw it on your blue sky. Oh gosh, yes. Now I remember.
Well,
I liked it.
what happened was I was inspired by what she did with the museums in terms
Mm-hmm.
of setting your beginning at one or zero, basically. And what this shows a sense of scale of change, but it loses the sense of scale. And so, like, you don't actually know California is losing. You can see because it's red, but you don't know that California is overwhelming the data set. And so, I was trying to, so like, this is not the correct one either. And so, when I did the first one, instead of doing change, I just did the number of colonies. But the problem is, the number of colonies in California are so large that no matter how you set your scale, you've basically got California in one color, North Dakota in like half that color, and everything else is a different color.
So I
Unless if
gotta
you do a
go, but
gradient.
I'm sorry, I have to go because I have another meeting. But just to you guys can stay if you want. I'm just gonna share a few thoughts at the end. So I've always thought that in order for you to tell a story, especially as complicated as this one, when it involves all the US states, which we already know the scale is never gonna match, unless you do it maybe by region, like let's just do Midwest, let's just do the Pacific Southwest, blah, blah. Um, Otherwise, you need several graphs to tell your story. I've
Right.
I've never heard that talked about before, but I think it's because it's logical. I think that we don't necessarily need just one graph that is going to solve all our problems and show all the things that we want. We need different ones and we need several. And then we need a way to also think about how we can divide our data in order to make it like in a little chunks that are easier to feed people, like with the regions instead of all the US, because that's going to be, like you said, California will never change when in reality it is changing, right? So, anyway, just my last thought. I will see everyone on Slack. I'm sorry I have to go, but I have another meeting. I'm at work.
Yeah. No, I think this was good. I think this was a good that I think that's a good stopping point. So I think
John,
that's
this
yeah.
was amazing. And I love that you reimagined your graph. You are, oh my God, you're the best. Please follow me on Blue Sky. I already follow you. And I'm excited to see what other things you come up with. This was brilliant.
Thank you.
Thank you.
Now the book has been really good for pushing that. All right.
I
Bye all.
agree. Bye, everyone. Bye, Vanetta. Bye, Hiram.